All right, welcome to this explainer. Listen, today we're looking at something that is absolutely going to shift how you view human history. Because, we usually think of the ancient world in terms of myths and empires and folklore, right? But the research we're unpacking today asks us to look at ancient history through a completely different lens. Instead of looking at the ancient Iranian world as just a bunch of religious traditions, we're going to analyze it as a highly advanced thermodynamic computational system. Yes, you heard that right. We are literally talking about a 12,000-year-old information engine designed specifically for human survival.
Okay, let's dive into this. Here is the system architecture we'll be exploring today. We'll start with the thermodynamic genesis, then move into programming error correction, and take a look at the physical lithic archive hardware. After that, we'll examine the administrative interface nodes, system failures and erasures, and finally, how all of this was reverse engineered to create what we now call modern science. So, starting right off with Section 1, the thermodynamic genesis. To really wrap our heads around this engine, we have to start at the very beginning. We need to establish that human reason wasn't just some, happy evolutionary accident here. It was a deliberate, calculated survival mechanism. These people were trying to survive extreme, volatile climatic shifts on the Iranian Plateau, and they desperately needed a system to prevent total societal collapse. So we are redefining ancient deities entirely today. Ahura Mazda? Actually, the energized synthesis of consciousness and logical work. And the architects behind all this were the Magi. Now, we usually picture them as wizards or mystics, but the root word, mogs, actually means brain. So think of them more like the ancient world's very first data scientists. They essentially acted as an IT department for civilization, processing unstable environmental data just to maintain order. And this brilliantly illustrates their core operating system. On one side, you have Mazda, representing the first law of thermodynamics. We're talking conservation, order, and the clear data signal. On the flip side is Ahriman, representing the second law of thermodynamics, entropy, chaos, the static noise. But here is the fascinating takeaway. Ahriman wasn't just evil in some traditional religious sense. No, it was the necessary friction required to actually extract the signal of Mazda. Without that constant, chaotic pull of entropy to push against, the engine of human consciousness would just slide right into thermal equilibrium, which, let's be honest, is really just a fancy scientific way of saying complete stasis, death. Which leads us perfectly into Section 2, programming error correction. So if you've got an engine that is constantly battling entropy, how on earth do you process the data without the whole system crashing? Well, you use the Recursive Error Correction Protocol, or RACP. Think of it like a giant self-improving software loop. Step 1 is the observation protocol, sampling that chaotic noise by meticulously tracking planetary and geomagnetic cycles over decades. Step 2 is dialectical filtering. Basically, if their observations didn't match their models, they didn't just ignore the bad data, they used it as a signal to recalibrate. Step 3 is standardization. They use the base 60 sextodecimal math system for lossless data compression over long periods of time. And as a quick aside, that is the exact same reason we still have 60 seconds in a minute today, which is pretty wild. Finally, step 4 is the feedback loop. They converted this high-level theoretical math into physical infrastructure to survive the harsh climate, like those massive underground aqueducts. It was a rigorous, absolute mandate to minimize entropy. All right, moving right along to Section 3, the lithic archive hardware. Because, as we all know, software needs hardware to run on. Storing this massive amount of complex observational data over thousands of years is a complete logistical nightmare, especially when you consider that paper or parchment just burns or rots away. I mean, imagine having to build a hard drive today that is guaranteed to last for 12,000 years. How would you even do it? Well, the ancients solved this by building what we call the lithic archive. These were permanent primary servers engineered entirely in stone. By aligning massive megaliths perfectly with the stars, they could permanently freeze high-density astronomical data into the landscape itself. This protected their scientific findings against inevitable data cleansing events, things like floods, massive fires, or wars. Now, what's really interesting about this timeline is the sheer multi-millennial scale of these global hardware deployments. This was definitely not just a local operation. Back in 10,000 BCE, Göbekli Tepe acts as the foundational anchor tracking long-term precessional cycles. Jump forward to 3200 BCE, and over in Ireland, Newgrange functions as a high-accuracy solar injection clock. By 500 BCE, Persepolis was literally functioning as a multi-layered computational array synced up to the constellation Cygnus. And this physical programming stretched across the entire globe, all the way over to Chichen Itza, acting as an intercontinental grid tracking Venus. So this wasn't primitive worship at all. It was a highly synchronized global hardware network tracking time and space. Essentially, they built a massive Wi-Fi network out of rocks. That brings us to Section 4, Administrative Interface Nodes. Having deep storage hardware is fantastic, for sure. But to actually run a functioning civilization, you have to network that thermodynamic logic outward to the general population. So these physical locations functioned as administrative interfaces. They were essentially the ancient world's internet routers. Around 3500 BCE, we see the Susa-Uruk corridor being used for early data compression for resource management. Then, the Zagros-Ebla interchange established scribal protocols to transmit incredibly dense math. There's even an entire axis linking Nile hydraulic management directly with plateau astronomy. And all of this culminated around 600 BCE with the Pesarghat protocol, which formally established the Ahura Mazdan framework as a state-mandated engine. These nodes acted as the critical routers transmitting the underlying logic out to the periphery.
But, systems crash. Section 5, System Failures and Erasures.
Like with any complex piece of technology, things can and absolutely do go wrong. What happens when data gets exported without the underlying operating system required to run it? You get systemic interface failures. As scientific capital migrated around the globe, the recipient civilizations became incredibly effective data harvesters. But the problem is, they didn't get the source code. Over in India, brilliant minds extracted geometric constants, but totally missed that thermodynamic struggle against entropy. China built these incredible armillary spheres, but treated the engine as a simple utility. And Greece? Well, brilliant minds like Ptolemy acted as custodians of the planetary data, but they focused way more on geometric aesthetics rather than the mandated need for error correction. So they had the files and they had the hardware, but they completely lost the operating system. And then you get the intentional crashes, the absolute deliberate deletion of data. Whenever severe global climatic volatility hit, dogmatic regimes stepped in and weaponized the chaos. They systematically purged the MOX, the actual brain of civilization, forcing the entire engine into a tragic state of information stasis. We see this immense loss in the destruction of the great libraries in 1200 BCE and late antiquity. We see it in 637 CE during the Sassanid Purge, which, by the way, literally criminalized probabilistic logic and incinerated vast, irreplaceable archives. And it happened yet again during the Mongol erasure, where environmental catastrophe was completely exploited by doomsayers as an excuse to reject science entirely. Let's move to and see how this builds into our final topic, Section 6, Reverse Engineering Modernity. So the crucial point here is that despite all those brutal erasures, the thermodynamic engine didn't stay buried forever. It was eventually rebooted. And this is the really wild part. What we now call modern science, according to this analysis, is actually a global, completely unconscious reverse engineering of this suppressed ancient logic. Think about it. Francis Bacon effectively resurrected the observation protocol. René Descartes rebuilt the mathematical synthesis. Johannes Kepler tapped right back into the planetary dialectic. Gottfried Leibniz brought back the concept of binary compression. And finally, Isaac Newton put all the pieces together to rebuild the completed engine. Without even realizing it, they reassembled the very same thermodynamic engine the ancient Magi had used millennia prior. Which leaves us with one final, pretty profound question. If modern science is really just a reboot of this ancient Iranian engine, what remaining secrets are still locked away inside that lithic archive? Fully restoring this Ahura Mazdan framework isn't just about looking backward with nostalgia. It's about decrypting a massive, silent code left in stone all across the globe. It's about restarting a stalled engine of human progress to once again push back against the chaos of entropy. It's an absolutely fascinating paradigm shift, and one that forces us to look at ancient stones not as primitive monuments, but as the servers of a civilization we are only just beginning to understand. Thank you so much for joining me for this explainer, and hey, keep questioning what you think you know.